All right, good day, everybody. Welcome to video number 6. I hope you all had a nice weekend. So, Bear walks into a diner and sits down in a booth, and the waitress comes over and she says, "Hi, can I take your order?" And the bear says, "Yes, I would like a grilled cheese sandwich." And the waitress looks at him and says, "Why the big paws, fella?" And the bear says, "Oh, I was born with them." Thank you very much. I'll be here all week. Alrighty, so let's get to it. Your homework, I gave you a couple more problems from the last section on page 154. And we have finished up chapter 3. And we finished up chapter 3 with the isosceles triangle theorem and the converse of it. If sides are congruent, then opposite angles are congruent, and vice versa. And hypotenuse leg was the last theorem we talked about. In two right triangles, if the hypotenuses are equal to each other and one of the legs, you can say the triangles are congruent by HL. So you now have 4 ways of getting triangles congruent. You have side, 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 angle, side, angle. These will work for any 2 triangles. If you get all 3 sides congruent, the triangles are congruent. If you get a side, the included angle, and a side congruent, the 2 triangles are congruent. And ASA, 2 angles and the included side. Remember, the included angle is the angle formed by the 2 sides that are congruent. The included side is the side that's in between the 2 congruent angles. So the congruent angles lie on opposite ends of that particular side. So be careful. Even though I have 2 angles and 1 side congruent, this is not NOT. This is not angle, side, angle, because this is not the included side. It's not in between the 2 congruent angles. And likewise, side, angle, side, be careful. Even though I have 2 sides and an angle congruent, I cannot say these triangles are congruent by SAS because this is not the included angle. And included, it has to be between the 2 sides. In other words, it has to be formed by the 2 congruent sides. So in order for these 2 triangles to be congruent by side, angle, side, this angle would have to be over here. As it stands, I don't know. They might be congruent, but I can't prove it. And then the last theorem we talked about only refers to right triangles, HL. Here I have 2 right triangles. The hypotenuse is congruent and 1 leg. Therefore, I can state deductively these 2 right triangles would be congruent by HL. They're still congruent by HL. Even though they don't seem to be resting in the same relative position, that's irrelevant. I have a right triangle, hypotenuse congruent to hypotenuse, leg, and a leg. These are congruent by HL. Okay? So let's go over the homework. Alrighty, on page 154, problem number 12. 154, problem number 12. Excuse me, first problem was number 8. Number 8, they said that you have this figure, triangle FGH, J. And the given information, the only thing they gave you that they said that, let me take this back. 154. Wrong problem. My bad. Number 8. They gave you this triangle, and they told you that this angle is 7x minus 18, and they told you that this angle is 4x. And they told you this is PQR, and they told you that the measure of P plus the measure of R is less than 180, and that PQ is less than QR. PQ is less than QR. So I know two things. The sum of these two angles, 7x minus 18 plus 4x, is less than 180. So from this equation, or inequality, just complete it just like an equality. The only difference between an equality and an inequality, you're going to do the same thing until you solve for your variable. In other words, if you're going to add or subtract the same number from both sides of an equation, it doesn't affect it. So I'm going to add 18 to both sides, and I'm going to combine the 7x and the 4x. I get 11x is less than, add 18, and I get 198. Now to solve for x, I have to divide by positive 11. Here's where an inequality is affected. If you multiply or divide an inequality by a negative number only, multiply or divide by a negative number, the order symbol turns around. I'm dividing by positive 11, so it does not affect the order symbol. 198 divided by 11 is 18. So there's my first part. I know x has to be less than 18. Unless I did something wrong. It said that P plus Q is less than 180. Yeah. Now, to get the other half, it said that that the PQ, side PQ, is smaller than QR. Well, we said that in a triangle, if sides are unequal, then the opposite angles are unequal in the same order. So since PQ is smaller than QR, it means that the angle opposite PQ, 4x, is smaller than 7x minus 18. This side's smaller than that side, therefore the angle opposite the smaller side, 4x, is less than the angle opposite the longer side. So solving this one, again, you solve an inequality exactly the same way you do an equality. The only difference is if you multiply or divide by a negative number, the order symbol turns around. So, in this particular case, I can either subtract 4x from both sides and add 18, or I could just subtract 7x from both sides. Let's do it that way so I can show you what happens. When you subtract 7x from 4x, you get negative 3x is less than negative 18. When you multiply or divide by a negative number, the order sign turns around. So if I divide by negative 3, I get x is greater than. The order sign turns. Negative 18 divided by negative 3 is 6. So now I know two things. X has to be greater than 6 and at the same time less than 18. You can put that together as in what is called a string inequality. X has to be greater than 6 but less than 18 in order for the information that they gave you to be true. So there are your restrictions on x. x has to be bigger than 6 and at the same time less than 18. So as long as you pick a number between 6 and 18, not including 6, not including 18, these are strict inequalities, strictly less than, strictly less than. And again, with a string inequality, from left to right, it has to be true. And this is, 6 is in fact less than 18. Something you cannot do, and it's a common mistake, is write a string inequality like this. 6 is greater than x, which is less than 10. Because the implication here is 6 is not only greater than x, but at the same time it's less than 10, but it can't be greater than and less than 10. In order to have a string inequality such as this, your order symbols all have to be facing in the same direction. Here I've got a greater than and a less than in the same string. Can't do that. That won't work. But this problem that we had, again, the restrictions on x, which is what the question was, write an inequality to describe it. Your string inequality ends up being 6 is less than x, which is less than 18. Okay? Again, if you don't understand that, make a note, ask me on Friday, or send me an email or call me. And there are, again, I told you that we will be talking about various topics from algebra throughout the course, and I will try to re-explain everything when we get to it, but these things pop up every now and then, and we haven't talked about them in class, so please make a note if you're confused. I'll be happy to explain it in class. So that was your first problem, number 8. Number 12. Number 12 was is number 12, again, I told you the word conclusion or proof is a 2-column deductive proof. If you see the word find, as you see in number 12, it is not a deductive proof, it is a numerical problem. They want you to actually work it out. So in this problem, they gave you a circle, and they said that this is circle O. Remember, you name a circle by its center, and they told you that PS is perpendicular to SR. And that angle P is 36. Okay? They said find the measure of angle PSQ and the measure of angle R. Now again, we haven't talked about the angles in a triangle, so there's got to be a way we can do this without using that fact, and there is. They wanted you to look at was this. Look at triangle POS. POS, that's a radius, that's a radius. All radii of a circle are congruent. That's another radius, so all 3 of these little line segments, which are radii, are congruent. That makes triangle SOP an isosceles triangle. I have 2 sides congruent. Therefore, I know by isosceles triangle theorem that this angle and this angle are congruent, so that's got to be 36. It's got to be the same as angle P. Now, you were told that this is a right angle. You were told these 2 line segments are perpendicular, therefore they have to form a 90-degree angle. 36 is this part, therefore the other part has to be 54, because the 2 added together have to add up to 90. And angle SOR is also equal, or is isosceles. Since these 2 are radii, therefore this angle has to be 54. So those are the 2 angles they were looking for, 36 and 54. This brings up another common error. I have 2 triangles here that happen to have 2 sides congruent, but I don't know anything else. I don't know that these triangles are congruent because I don't have side, side, side. I don't have side, angle, side. I don't have angle, side, angle. All I have is two triangles with two sides congruent in each triangle. I know for a fact that in triangle ABC, this angle has to equal that angle. Does that necessarily mean in this triangle, these angles are congruent to these two? And the answer is no, N-O. It's very common to say, oh yeah, look, they're opposite equal sides, therefore they're all congruent. But these could both be 40, and these could both be 20. So these angles have to be congruent, these two angles have to be congruent, but all four of them do not have to be congruent unless you somehow can prove the triangles are congruent, which you can't. Given only the two sides, I have no idea whether the angles are, all four angles are congruent. Common error. So be careful. Hopefully you understood this problem. That was number 12. And then the last problem, number 23. Number 23 is a proof. And you've got two circles that intersect. They gave you circles O and P, and not very well drawn, fairly sloppy, don't worry about it. They told you that AB bisects angles OAP so AB, this segment bisects this angle OAP, and it bisects angle OBP. And they asked you then to prove that the figure triangle or figure AOBP is equilateral. And hopefully you remember the definition of equilateral, all four sides congruent. All sides congruent, in this case all four. So what I want to prove, if you simply say the following, if you're done. If you can prove OA is congruent to OB, which is congruent to OA, OB, PA, and PB. If I can prove all four of these line segments are congruent, I'm done. It's equilateral. That was what the definition was. Or you can just simply state this. So we have to prove that all four of these things are congruent. All right? Now, there's a couple of ways I can approach this proof. There's two absolutely, totally different ways. I'm just going to do one of them. And I told you as we get more and more information, the number of ways of attacking a particular proof will increase. You can do the same proof many different ways, and all of the different ways are going to be 100% correct. Here's one way. First entry you're given. All right, now call that 1, 2, 3, and 4. Since you were given that AB bisected this big angle and it also bisected that, I know angle 1 is congruent to angle 2. I know angle 3 is congruent to angle 4. Definition of angle bisect. An angle is bisected if it's cut into two congruent pieces. Okay? So I've got this congruent to that. I've got this congruent to that. Which then gives me one more step. AB is congruent to itself. Reflexive or identity. Which tells me these two triangles now. Triangle AOB is congruent to triangle APB by ASA. Angle, common side, angle. And since they're congruent, that means that OA is equal to PA, and it also means that BO and BP are congruent. By CPCTC. Remember, this can never be used before you've got triangles congruent. All right, once those are congruent, then I can make the following statement. In circle O, OA and OB are radii. Therefore, they're congruent. In circle P, PA and PB are radii. Therefore, they're congruent. Radii of a circle are congruent. Putting statement 5 and 6 together, I've got OA congruent to PA, but OA is also congruent to OB or BO. BO is congruent to BP, BP and PB. All of them are congruent to one another, therefore, by transitive property or substitution, and you're done. OA, OB. Remember, your last statement is always going to be the statement you're trying to prove. So OA is congruent to OB, is congruent to PA, is congruent to PB by substitution or transitivity. In this case, they both work. Remember, if you don't know which to put, always put substitution. You can't go wrong. If you wished, you could have made one more statement. I would, again, if you had a problem like this on a test and you stop there, you're done. You could have also said then, the figure is equilateral by definition. That's fine, but you don't need it. It's not necessary. This will be acceptable. Okay? Hopefully you all followed that. Okie dokie. Then you had problems on page 158. And the first problem number 3. In problem number 3, you were given a circle. In this, you're given that the YO is congruent. Again, this is not drawn to scale, doesn't matter. You were told YO is perpendicular to YX, and you were told that OZ is perpendicular to ZX. And they wanted you to prove that YZ and XZ are congruent. Hopefully you recognize, looking at this, I don't have any triangles yet, but I can get a triangle by using the line postulate. Again, you're given information, these two segments are perpendicular, these two are perpendicular, prove this segment and that segment, XY and XZ are congruent. One given. 2, I can say angle Y is congruent to angle Z. Right angles are congruent. And I know they're right angles because they're perpendiculars, and I told you anytime you have perpendiculars, you can automatically jump to this. These angles are right angles, therefore they're congruent. At this point, I can't go any further unless I insert an auxiliary set, an auxiliary line. And what I want to draw is OX. And I do have to put that in the proof. Draw OX. And again, I mentioned when you put an auxiliary set in, draw it dashed so you know it wasn't there to start with. And the reason I know I can do that is the line postulate. Any 2 points determine a line segment, or array. All right, now look what we got. I've got 2 right triangles. OX is the hypotenuse of both. It's congruent to itself. Reflexive or identity. And hopefully you recognize OY is congruent to OZ. They're radii of a circle. And radii are congruent. Now I have 2 right triangles with the hypotenuse and the leg congruent. Therefore, the triangles are congruent by each other. OYX is congruent to triangle OZX by HL. Hypotenuse, the common line segment OX, they're congruent to each other. And the 2 other, the legs OY and OZ are radii of the same circle. And we are now done. Since the triangles are congruent, YX equals YZ. YX is congruent to YZ. CPCTC. Once you get triangles congruent, then all corresponding parts of one are congruent to all corresponding parts of the other. Number 3. Okay, hopefully you followed along with that one. Bada boom, bada bing. Here we go. All right, next problem was number 5. And number 5, it says set up and prove. This is something we're going to talk about formally today. I told you last week on Friday we had a problem where you were just given a statement. And again, I told you you're going to see these start popping up more and more frequently. And again, we'll talk about it formally today. But when you're given a statement, you have to first draw a figure and label it, and then have a given statement based on the way you've got your figure drawn and labeled, and a proof statement based on the way you've got your figure drawn and labeled. So in this case, they said set it up and prove. The altitude to the base of an isosceles triangle divides the triangle into 2 congruent triangles. So what you've got to do is the following. You've got to draw a figure and label it any way you want. Now, when you're given an isosceles triangle, they don't tell you which 2 sides are congruent. So once you've drawn your figure as part of your given, you actually have to state what sides do you want congruent. So I'm going to say with AC congruent to BC. Just because it's isosceles, that doesn't mean those 2 sides. It could have been these 2 sides. So you actually have to state which ones you want as congruent. And then it also says the altitude to the 3rd side. They told you CD and altitude. And then they asked you to prove that the altitude divides the triangle into 2 congruent triangles. So you're trying to prove, by the way I've drawn this, that CDA is congruent to triangle CDB. So here I have a statement turned into a drawing, labeled. I have a given statement in terms of the way that I have drawn the figure and labeled it, and a to prove statement. Now I can do my proof. Given. I know that I can call that 1 and 2. Angle 1 and angle 2 are right angles, therefore they're congruent. and they're right angles, making this a right triangle. Statement 3, CD is congruent to itself. Reflexive or identity. Now, in this particular set of triangles, this common side is a leg. CA and CB are the hypotenuse. Therefore, the two triangles, CDA and CDB, are congruent by HL, hypotenuse, leg, and you're done. So you have taken that statement, turned it into a figure, labeled the figure. You have listed your given and your proof statement in terms of the figure you have drawn and labeled. Then we did our proof. And that is that, number 5. Everybody good? Okay. Number 10. Number 10, again, you're given a circle. And so you're given circle P, and you were told that ST is congruent to VT, and you were asked to prove that angle PST is congruent to angle PVT. All right, as this is drawn, I don't have any triangles, so somehow I'm going to have to get triangles, and there's 2 ways I could do that. I can either draw PT or I could draw SV. There's 2 totally different ways of doing this proof. I'm going to just show you one of them. I'll give you a quick explanation of the other. Given. Statement 2, draw PT. Line postulate. Any 2 points determine a line or line segment. It's an auxiliary set, so draw it dashed. I know that PT is congruent to itself. Reflexive or identity. I also have a circle with 2 radii, SP and VP. Radii are congruent in the circle. Since I now have 2 triangles with all 3 sides congruent, I can say the 2 triangles, triangle PST and PVT, they are congruent to one another by side, side, side. All 3 sides are congruent. Since all 3 sides are congruent, the triangles are congruent, and that then makes angle PST congruent to PVT, which is what you were asked to prove. By CPCTC. Again, for the umpteenth time, you can never use CPCTC until you have first proven triangles congruent, which I did in this step prior. That was number 10. That's the one way to do it. Hopefully you followed along. Again, if ever I give a problem, and even watching it after watching it, maybe stopping and watching it a second time, if you don't understand it, write a note. I'll be happy to answer on Friday any questions that you have on this homework, or call me or email me. Let me just give you a quickie on the other way. Totally different, totally different. So we started just with ST and VT congruent. You can get SP and VP congruent. They're radii of a circle. And the other way to do it was draw SV. I now have two triangles, triangle SPV and triangle STV. Each of these two triangles are isosceles. So I know that and that are congruent in this triangle SVT. They're opposite equal sides. In the little triangle SPV, I've got this angle congruent to this angle. Same reason, isosceles triangle theorem, and then by addition, you can get the big angles congruent. Totally different way. But which way is better? It makes no difference. What's important is which way you saw it. So if you happen to see it the first way, that's great. If you happen to see it the second way, that's equally great. They're both ways would have been perfectly correct. And again, you're going to start to see that more and more often as we get further into the course and you get more and more information. Number 14. Number 14 is a find problem, so it is numerical. Again, you started out with a triangle ABC. They told you that this side is 4x plus 48. And they told you that this is 8 minus x. And you were told that the angle A is greater than angle C. Angle A is greater than angle C. So this is that converse ITT. If in a triangle angles are unequal, or excuse me, this was the theorem that said if sides or angles are unequal, then their opposite sides or angles are unequal in the same order. Since these angles are unequal, the sides opposite will be unequal in the same order. So I know for a fact, since angle A is greater than angle C, then the side opposite angle A, 8 minus x, has to be greater than the side opposite angle C, 4x plus 48. Okay, now this one, you had to think about this for a bit. I know that in any triangle, I cannot have a negative side. Triangle sides have to be greater than 0. So I have to keep that in mind when I complete this problem. This is not going to be the only thing that we're going to solve. This is going to only give me part of the answer. And if I solve this one, again, I can either bring the x over by addition or I could bring the 4x to this side by subtraction. It doesn't matter. When you add or subtract, the inequality symbol is not affected. The inequality symbol is only affected if you multiply or divide by a negative number. So I'm going to just add x to both sides. Subtract 48 from both sides, and I get negative 40 is greater than 5x. To solve for x, I'm going to divide by positive 5, both sides. When you multiply or divide by a positive number, nothing is affected. And I get x has to be less than negative 8. X has to be less than negative 8. Hopefully everybody followed that. Now, I cannot just stop there because that only gives me part of the answer. Like, not every number less than negative 8 is going to make both of these positive. Any number less than negative 8 will make that positive. 8 minus any negative number less than negative 8 will always be positive. But this one, not so. There are numbers I could put in for x that would make this side negative. Like if I pick the negative 10 or a negative 20. 4 times negative 20 is negative 80. Negative 80 plus 48 is a negative number, negative 32. I cannot have a negative side of a triangle. And again, if I plug in any number, negative 8 or less, this will always be positive. Because when you subtract a negative number, it becomes positive. So I don't even have to worry about this. This covers this side. However, this doesn't cover this side totally. I can pick a lot of numbers less than negative 8 that would make 4x plus 48 negative. So I need also the following. I also need 4x plus 48 to be greater than 0. It has to be positive. Positive is greater than 0. So I get 4x has to be greater than negative 48. Divide by 4, and you get x has to be greater than negative 12. Any number that I put in bigger than negative 12 will make this side positive. But now I have to put these two together. X has to be greater than negative 12, but less than negative 8. You can put that as a string. Negative 12 has to be less than x, which has to be less than negative 8. This is now a proper string because negative 12 is in fact less than negative 8. So from left to right it works. The string works because the symbols are in the same order. They're both less than. So here is your final answer for that problem. X has to be greater than negative 12, but less than negative 8. If you plug in any number between these two, both of these sides will be positive. And remember, in a triangle, we are only going to talk about triangles with sides positive. We cannot have a negative value for the side of a triangle. And that was it, I believe. So again, any questions? If you're totally stumped by one or two of these problems, please make a note, and we'll clear it up on Friday, or call me or email me. And again, if you haven't noticed, they throw in little bits of algebra pretty much all the time. So you're keeping on your toes. Hopefully your algebra skills you either remember or you're refreshing. Because you're going to get a little bit more today. The first thing we're going to talk about today on a coordinate plane. If I gave you any 2 points, if I called this point P and this point Q, and I connect it, I've got a line segment. And X, I'm going to call this X1, Y1. These little subscripts, X sub 2, comma, Y sub 2. The little subscripts with X and Y are different, which means that the X's and Y's are different. So this might be the point 4, 4, and this would be the point negative 2, negative 1, or negative 2, 1, or anything. It just means they're different. If they have the same subscript, then they're the same value for X and Y. So you use the little subscripts to determine different values for X and Y. Now, hopefully you realize PQ is a line segment. Every line segment can be cut in half, and it is cut in half at its midpoint. So the midpoint is somewhere in here. Call it M. And in algebra, I hope you did this, but you might not have. You had what was called the midpoint formula. And the midpoint of any line segment, if you know the coordinates of the endpoint, the midpoint is always the average of the x's, the average of the y's. Average means you add them together and divide by 2. There's your midpoint formula. Average of the x's, average of the y's. Let's give a real number solution. Just remember this. Average x plus 1, x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. So if I gave you the following 2 points, if I gave you the point 5, 5, and the point negative 2, negative 3. What's the midpoint? The midpoint, add the two x's together. 5 plus a negative 2. 5 plus a negative is minus over 2. 5 plus a negative 3 is 5 minus 3 over 2. 5 minus 2 is 3, so I get 3 halves, 1 1/2. 5 minus 3 is 2. 2 over 2 is 1. So the midpoint is 3 halves, going to be right in here. This coordinate will be 3 halves, comma, 1. So be careful when you add a negative. Remember, it becomes negative. When you subtract a negative, it becomes positive. But the average, you add the two x coordinates together. 5 plus a negative 2 is 5 minus 2 over 2. 5 minus 2 is 3. 3 over 2 is 3 halves. Average the y coordinates. 5 plus a negative 3 is 5 minus 3, which is 2 over 2, which is 1. The midpoint has the coordinates 3 halves, comma, 1. You're going to see problems like the following. Which makes it a little more complicated, but not terrible. Here you're given the coordinates of the midpoint, and you've only got one of the two endpoints. How do I find the coordinates of point Q if 1, 1 is the midpoint of PQ? Well, the midpoint formula says x plus negative 4, so x minus 4 over 2 is equal to 1. And likewise, y plus 3 over 2 is equal to the y coordinate, 1. Solving, you get x minus 4 equals 2. Just multiply through by 2 to remove the fraction. So x minus 4, add 4 equals 6. Y plus 3, subtract 3, and you get y equals negative 1. Again, the drawing is not to scale. Don't worry about it. This point would have to be the point 6, comma, negative 1. Hopefully you followed that. So if you're given the midpoint, and you're given only one endpoint, you still use the midpoint formula, but you're solving for the coordinates of the other endpoint. Midpoint formula. Hopefully that rings a bell from algebra. Maybe, maybe not. But hopefully it does. Okay. Alrighty. We talked about this. We had a problem just a few minutes ago. I told you we would formally talk about it. The missing diagram problem. In other words, you're only given a statement, and you have to take that statement and convert it into a drawing that you label. Then you have to list your given information in terms of the figure that you have drawn and labeled, and the to prove statement in terms of the figure that you've drawn and labeled, and then you have to do the proof. So anytime you're given an if-then statement, so if I say if a triangle is such and such, then the if part is what they're giving you. It's called the hypothesis. The conclusion, or the then part, is what you're asked to prove. So you've got to take the info and convert the info into a figure, and then label your figure, list your given in terms of the way you drew your figure and label, and then do your proof. What's your proof? You also have to put your two proof statements in terms of the figure that you've drawn. So an example of this, on page 179. If you all turn and look at the problem number 9 on page 179, it says, the line segments joining the vertex angle of an isosceles triangle to the trisection points of the base are congruent. The line segments joining the vertex angle of an isosceles triangle to the trisection points of the base are congruent. So what I've got to do is draw a figure. All right, it says you're given an isosceles triangle, and I told you if you're given an isosceles triangle, when you draw your figure, you have to say, as part of your given, which of the sides you want as congruent. So I want AC congruent to BC. And then it said the line segments from the vertex to the trisection points of the base. So let's call these X and Y. So X and Y trisect AB. And now I can write my proof statement. It said prove that these line segments from the vertex to these points prove that CX is congruent to CY. Prove that those segments are congruent. And again, a couple of totally different ways to do this one. I'm going to show you one. Given. All right, now, in the big triangle, forget about these two line segments. I know AC and BC are congruent. Therefore, in the big triangle, the angle's opposite. And again, this is not the only order. You could change the order of these steps. I can say angle A is congruent to angle B. ITT. If sides in the triangle are congruent, then opposite angles are congruent, and vice versa. Now I'm going to use this. X and Y were trisection points, therefore I know that AX is congruent to XY is congruent to YB. I don't even need XY, but you can throw it in there, it's not wrong. That's definition of trisect. Trisect means it's cut into 3 congruent pieces. Hopefully now you recognize these 2 outside triangles. Triangles CXA and CYB are congruent by side, angle, side. Side, angle, side. So I've got triangle CAX congruent to triangle CBY. By SAS, since they are congruent, corresponding parts CX and CY are congruent by CPCTC. And we have taken a statement, converted it into a figure, labeled. We have listed what was given in terms of the figure that I drew and labeled. And we have written our proof statement, what we're trying to prove in terms of the figure that we have drawn and labeled, and we've done the proof. And you're going to start to see this, not frequently, but it's going to happen from now on, where you are only given a statement and you have to convert that into an actual drawing and then a proof. Okay? And that's really all I'm going to talk about for today. So, any questions you might have, again, feel free to give me a call or email me. But the homework for Friday, please, on page 179, 173, numbers 2, 4, 13, page 178, number 12 and 14. 173, 2, 4, and 13. 178, numbers 12 and 14. And I look forward to seeing everybody. Have a nice remainder of the week. I think the weather's supposed to be nice. And I will see your smiling faces on Friday. Thank you very much.